Hello everyone. I hope you all are keeping good health. Today we will start with a new chapter, chapter 6, the triangle and its properties. First of all, what is triangle? A triangle is a simple closed figure made up of three line segments. Here you can see this is a triangle which we named as ABC. Here, vertices are A, B, C as they are the meeting point of two line segments. Next is AB, BC and CA or AC are the sides of the triangle. Angles are angle BAC or CAB or angle A. We can name our angle in three ways, either by a single letter or by using three letters in any pattern. Next is angle ABC or CBA or angle B. Next is angle ACB or BCA or angle C. Next, what is side opposite? Now, this is a triangle ABC. Here we are supposed to find side opposite of a vertex A. Now, opposite of A is BC. Or we can say in a triangle ABC, except A, we are left with BC, so side opposite is BC. Similarly, for B, it's AC. For C, it's AB. The same thing we will do for the angle. Side opposite of the angle BAC will be the side which is not as the arm of the said angle. So it's BC. Similarly, ABC or side opposite is AC. Angle BCA side opposite is AB. Now, classification of triangles. We can classify triangle in two ways. First, on the basis of sides. Second, on the basis of angles. First, you will cover sides. There are three types of triangle. Scalene, where all the sides are different. Here you can see in triangle ABC, all the three sides are different. Next is isosceles. Here, two sides are equal. Here in triangle ABC, AB and AC are equal to each other. Moving to the next triangle, that is equilateral triangle. Here all the sides are equal. Now, classification of triangle on the basis of angles. It's acute angled triangle where all the angles are acute. Next is obtuse angled triangle where one of the angle of the triangle will be obtuse. Next is right angled triangle where one of the angle of the triangle is right angle. I hope the classification is clear to you on the basis of side as well as on the basis of angles. Moving to the next topic, that is medians of a triangle. Now, what do you mean by median? Let us consider this triangle. We are supposed to draw a median from A. Now, side opposite of A is BC. To draw the median, we will find out the midpoint of BC. Let it be D. Here, as D is the midpoint, so BD and DC both are equal. Now, you will join AD. As A is joined to the midpoint of the opposite side, so here AD is the median. Similarly, if you want to draw a median from B, so opposite of B is AC. we will find midpoint of AC. Let it be E. Join BE. Here BE is the median. Similarly, go for C. Side opposite is AB. Midpoint is, let it be F. As it's a midpoint, so AF is equals to BF. Join CF. Here CF is the median. So we can conclude it as a median connects a vertex of a triangle to the midpoint of the opposite side. You can keep it in mind by M for median, M for midpoint. So in case of median, we will connect a vertex to the midpoint of the opposite side. Now, you can tell me that how many medians can a triangle have? Yes, a triangle can have 3 median as it has 3 vertex. Median is possible through vertex, and because there are 3 vertex, we can draw median from all the 3 vertex, and so there are 3 median in a triangle. Now, moving to the next topic, it's altitudes of a triangle. Now, what is altitude? Altitude means height. In case of triangle, how will you find the altitude? Again, considering the same triangle ABC. Now let us suppose that we are supposed to draw altitude from vertex A. So we will draw a perpendicular line segment from A to its opposite side. Yes, as it's a perpendicular line segment, so it is making 90 degree to opposite side. Now this AD will be the altitude. Similarly, if you want to draw it from B, you will draw a perpendicular line segment from B on its opposite sides AC. Perpendicular line segment means it will make 90 degree. Next, let's suppose we are supposed to draw an altitude from vertex C. Again, use the opposite side AB, draw a perpendicular line segment which will make 90 degree to the opposite side. This is the altitude. So we can say altitude as the perpendicular line segment from a vertex of a triangle to its opposite side. So in case of median, we are connecting vertex to the midpoint of the opposite side. And in case of altitude, we will connect the vertex such that it will be perpendicular to its opposite side. Moving to exercise 6.1. Question number 1. In triangle PQR, D is the midpoint of QR. It's clearly given to you that D is the midpoint. So QD and DR will be equal to each other. Now, we are supposed to find out what is PM here. Now, checking PM. Here PM is making 90 degrees. It's a perpendicular to the opposite side. So, it's an altitude. Next, what is PD? PD is a line segment which is joining P to the midpoint of opposite side. So, it is median. Next, we will check whether QM is equal to MR or not. Now, comparing the two, you can see that they are not equal. So, answer is no. Moving to question number 2. Draw rough sketches for the following. In triangle ABC, BE is a median. We will draw a triangle ABC such that BE will be on the top, that is about the base. It will be easy for you to draw the median then. Now, as you are supposed to draw the median from B, the opposite side is AC. First, find the midpoint of AC and join to BE and mark it as E. And this BE is the median. Moving to next question. Here in triangle PQR, PQ and PR are altitudes of the triangle. But as per the given triangle, PQ and PR are the sides of the triangle. Now, in which triangle the sides will act as the altitude? So yes, altitude means a straight line. So two sides are straight. This you will get in right angled triangle. So here this is your answer, where you can see that PQ and PR are perpendicular to each other. So they are acting as altitude of the triangle. Next is in triangle XYZ. YL is an altitudes in the exterior of the triangle. We are supposed to use a triangle such that when you will draw an altitude from a vertex Y, it should fall outside the triangle. It is possible only if Y is not above the base. It means it will be either on the left hand side of the base or on the right hand side of the base. That is, it is an obtuse angled triangle. Now when you will draw a perpendicular line segment from B, it will fall outside the triangle, extending XZ in the back direction. Yes. The meeting point is L. Here, YL is an altitude which is in the exterior of the triangle. Moving to question number 3. Verify by drawing a diagram if the median and altitude of an isosceles triangle can be same. Now we are supposed to verify this. For this, we will start with draw an isosceles triangle. Here, this ABC is an isosceles triangle as AB and AC are equal to each other. Now, you will mark a midpoint D on the side BC, which is opposite of vertex A, such that BD is equals to DC. Now when you will join this A to the midpoint of the opposite side BC, you will get a median AD. Now you have to check whether this median is acting like altitude or not. So we will measure it by using protractor. If it is 90 degree, so AD is altitude. So as the same line segment is considered as median in the third point and the same in the fifth point as altitude, so we can say that yes, median and altitude of an isosceles triangle can be same. Moving to the next topic, that is exterior angle property of a triangle. Exterior angle means an angle that is not inside the triangle. Let this be your triangle. Here we are extending AC backward and marking it D. Now here these three angles marked by arcs are interior angle, whereas angle BAAD or DAB is an exterior angle. Now, as per exterior angle property, the exterior angle will be equal to the sum of interior opposite angle. You can write it as an exterior angle of a triangle is equal to the sum of its interior opposite angles. This property you can use to find the value of exterior angle if the interior opposite angle is known to you. Or you can use this property to find one of the missing interior opposite angle if exterior angle is clear to you. Moving to exercise 6.2. Question number 1. Here we are supposed to find the value of x, as it's clear by the diagram that x is an exterior angle and the interior opposite angles are clear to you. So we will use exterior angle property, which means x is equals to 50 degree plus 70 degree. We are supposed to mention the property next to it. Adding the two on the right hand side, you will get the answer as 120 degree, which will be the value of x. Next, again, x is an exterior angle and the interior opposite angles are given to you. Using the exterior angle property, x is equals to 65 degree plus 45 degree, mentioning the property next to it in the bracket. Solving the right hand side, you will get the value of x as 110 degree. Next is this diagram. Here again, you are supposed to find the value of exterior angle, which will be equal to sum of interior opposite angle by exterior angle property. Adding the two on the right hand side, you will get the value of x as 70 degree. Next, we are supposed to find the value of exterior angle, that is x, which is equal to 60 degree plus 60 degree by exterior angle property. Adding the two on the right hand side, you will get the value of x as 120 degree. Next, question number 2. Here, exterior angle is given to you, but one of the interior opposite angle is missing. Again, using the exterior angle property, here exterior angle is equals to sum of interior opposite angle. Shifting 50 degree to 115 degree. Yes, the sign will get changed. Subtracting the two on the right hand side, you will get the value of x as 65 degree. Now, again, exterior angle is given to you and one of the interior opposite angle is missing. So you will write exterior angle as sum of interior opposite angle by exterior angle property. Again, you will get the value of x as 100 degree. Shifting the 70 degree, we will get minus 70 degree. Solving the two, x is 30 degree. Yes, again using the same logic, 120 degree is an exterior which will be equal to sum of interior opposite angle by exterior angle property. Here we are supposed to find the value of x, shifting 60 degree to 120 degree side. The value will get changed. You will get the answer as 60 degree. Next, Again, exterior angle is equals to sum of interior opposite angle by exterior angle property. So yes, shifting 30 degree, you will get the value as 80 degree minus 30 degree. Solving the two, you will get the answer as 50 degree. I hope both the topic of exercise 6.1 and 6.2 is clear to everyone. Thank you everyone for watching the video. God bless you all.